Okay, moving on to the next video. This is exercise 5 and essentially builds on those videos and those tutorials that you've gone through previously. So at this stage now, you should be pretty well able to do the LCC calculations. What we're going to do in this video, or what we're going to accentuate in this video, is doing the calculations but then putting them into some sort of methodology. The methodology we're going to use is the ICMS. The ICMS version 3 includes life cycle costing and carbon emissions, as well as capital costs, and it provides a breakdown structure, not completely dissimilar or similar to the National Standard Building Elements, but there is some key differences, particularly the fact that now we've got a consistent methodology in life cycle costs and we've got a similar methodology in carbon emissions. So what I'm going to show you in this particular tutorial is inputting your life cycle costs, which is very similar to what you've done before, but putting them in categories based on the ICMS. Now you can have a look at that ICMS yourselves. We've done it in class. Look at the breakdown structure, look at the groupings, look at the subgroupings, and kind of try and establish where different life cycle costs could go in terms of their groups. I have also taken, for the purposes of this tutorial, you'll actually find the ICMS at this particular web page, International Cost Management Standard, ICMS-coalition.org. So you can download it there. You can also get a kind of a download of the ICMS 3 explained. And for the case of this particular tutorial, you can download an Excel spreadsheet version of the breakdown structure of the ICMS. So the ICMS itself is in PDF with a lot of explanation in relation to what it is, how it can be applied, but it basically takes the appendices in terms of breakdown structure, puts them into Excel and provides that those sheets for you, so you can download that. What I've done is I've downloaded and I've taken out the sheets that are applicable to life cycle costing. So there's a lot in the ICMS, but I've taken out the 6 or 7 sheets or 4 or 5 sheets that are applicable to what I want you guys to do in the nature of this exercise. Those sheets are in blue. So we've got acquisition costs, that's the coding structure. You've got construction renewal and maintenance costs, which is category 2, 3, and 5 of the ICMS. And then you got your groupings and your subgroupings. Now, just to let you know, we're not going to go down to the level 4 detail in the ICMS. We'll go as far as level 3, which is essentially the group heading, not the subgroup heading. Generally, that's the case when you do a life cycle cost exercise. You won't go to the granular detail you might go into when you're doing construction costs. So just note that we're not really paying a whole lot of attention to what's in blue here, or light blue, I guess, in terms of a breakdown structure. So that's the codes for construction renewal and maintenance. And then category 4 is operations, subgroups and groups. And then item 6 is end of life. So they're the kind of main categories, and then within each main category, then you've got your kind of groups, and then within the groups, you've got your subgroups. So something that you're kind of somewhat familiar with because you're used to looking at the National Standard Building Elements from a coding structure, but this provides a little bit more detail in terms of breakdown. That's the summary page, template for life cycle costs for a project. It's got that ICMS heading. So this is the kind of summary breakdown structure that's provided in the ICMS when doing life cycle cost exercises. So I'm going to use that, why not? It provides a nice breakdown structure whereby we can kind of feed our costs into. Now you can do it manually, or I'm going to show you kind of a quick way where you might automate that process using some Excel formula. So as I said before, life cycle costing, the better you are in terms of using Excel, the more advanced Excel user or spreadsheet user you are in terms of its functionality, its formula, even using macros, generally the better life cycle cost template or exercise you'll kind of be able to pull together. So obviously your expertise in Excel in terms of spreadsheets, use of spreadsheets, and then your knowledge of life cycle costing kind of go hand in hand. Okay, so this is the input sheet. Now, again, you can use something that I'm proposing here, add to it, change it, or use something you have yourself, or maybe use a different version of the tutorials or different exercises from the tutorials to kind of pull this information together. I'm not paying a whole lot of attention to a kind of a format and presentation in this input sheet. I'm just inputting the item, the life cycle costing item, whether it's from the bill or the cost plan, or whether it's an operations cost item like water costs, electricity costs, gas costs, etc. So ultimately I want a code, and then I want the grouping, and then possibly the subgrouping that code is. So in this case here, we've got internal walls, stud partitioning. It's item 3, which is renewal costs, and then 04 is architectural works non-structural. If you want to see that, you can go back to that sheet there and have a look for that particular item. So it's category, as I was saying there, it's category 3, which is renewal costs, and then 2, 3, and 5 is the same kind of subcategory structure, and then you scroll down to 04, that's architectural works / non-structural works. You can go down to that level of detail there, but for the purposes of what we require in terms of a summary page, we don't have to do that. So I've got an example of about 7 or 8 items here, but of course you could keep going with different items from your cost plan, or different operations and maintenance costs, end of life costs. So all I really want to do is essentially show you a flavor of a number of different items, and for a project you could be working on, or for a project in work, you could be essentially adding how many other items you might think goes into that life cycle cost exercise. So this kind of format is something that's familiar for maybe the second or third exercise that you've done. We'll put the lifespan in here. We've got our gross internal floor area, we got our inflation, we got our discount, and then obviously, as we've done before, we calculate our real discount rate, our real discount factor, or DF, from those two rates. One's essentially offset against the other, but through a kind of a standard discount formula there. Ultimately, life cycle costing is an exercise in cash flow, so that's what we're going to move on to here. So we're going to start with the real cash flow, so in today's money, and then we'll move on to over 60 years, and then we'll move on to the net present value, the discounted cash flow. Now you could put in the escalated cash flow in there as well, but we don't want to make it too complicated. This is the discount rate applied to each item. The reason I put it in there as a column ultimately is that maybe there might be one item that could be different because a different inflation rate is applied. So you'll get utilities, things like gas and electricity, may increase at a greater escalation rate or inflation rate than some of the other construction goods and services. And in that case, it'll increase inflation, but it'll decrease my discount factor, my real discount factor. Whereas in another exercise, we might apply just that same real discount factor to every item. In this case, I want the ability to be able to do it kind of line by line. So you can get a feeling that life cycle costing there's no right way of doing it. There's no right way of laying it out. I'm kind of proposing a number of different scenarios. You can use them, use a combination of them, or use something different. Ultimately, you're building your knowledge in life cycle costing, and then you apply it in whatever context you want to apply it based on the scope, the complexity, and the different stage of the project you're working on, whether it's a concept stage or something more detailed. This is a fairly easy, simple spreadsheet to follow. You could build it out with graphs, additional information, cover page, summary page, etc., etc., and then maybe run some cash flow analysis and cash flow scenarios off it as well. I'm not going to get into every line item. I propose here some formulas that you can kind of just take and then follow. Some of them we've done before, others will be new. What I need to do here is find a way to calculate the different categories, so the costs within the different categories from a line by line item perspective, and I can use Excel to do that. So let's start with this, and let's start with the real cash flow. We used this mod function before, if mod, so that's essentially pulling or finding the costs that's attributed to different line items and applying it to the correct cash flow. So if I'm replacing it every 20 years, then it'll put it in 20 years, 40 years, 60 years. Also, I'm using an uplift factor here. So this could be the construction costs I'm pulling from the cost plan. It's getting replaced in 25 years, but I obviously need to allow for the fact that I'm taking out the old item. So I'm going to uplift that to account for disposal. and to count for demolition, etc. Some items I don't need to uplift, and others I do because there's a bit of demolition and extra costs involved in that. And that's pretty standard with life cycle costing, that we take the original cost as a kind of a like-for-like replacement, and then we'll uplift it, obviously, because we need to get, it's not escalation, it's not inflation, it's actually accounting for the fact that we've got some extra costs in replacing something rather than actually just building it for the first time, building it new. So that's that. So let's just start with the first item here. And again, just be aware, using the little dollar signs, lock cells, lock rows. And that's essentially important when you're kind of filling across and filling down formulas, that if you don't lock certain cells and rows, you'll lose that functionality or that kind of methodology from what you want to achieve in terms of selecting certain cells. So put a little comma in front of that formula just to kind of show it, otherwise it'll run it. So I'm going to just delete that. So have a look at that formula. It's the exact same one that you used, I believe, in the last sheet. Or the last exercise. No cost is going to be applied in this first item for year 1 because it's only getting replaced in the 25th year. So let's run this across and let's see, does it apply it in the 25th year and the 50th year? And it does, and you can't see it there, it's off sheet, but it does apply it in the 25th year. So I'm going to pull that entire column down. Now the column has to be highlighted and with the little kind of crosshair, as you're aware. I'm going to bring it all down there, and all those formulas fill down because I locked certain cells, rows, etc. So if you wanted to test one, you see that it's pulling from that cost on that particular row in that particular column against that particular year. It's filling it out for every year for 3 or 4 different line items there because they're operational items that happen every year. So these ones, first 4 or 5, are at different intervals, and then I guess there's a number of them there in maintenance and operations costs that happen every year. So costs, life cycle costs, can happen every year, they can happen every number of years, or they can happen just once. In this case, end of life at the end of the study period. And you'll see that last item should be there, and it's there in the 60th year. So now we got a discount. They're the real costs, and you can see they're the same costs year on year. But we need to discount them with a discount factor. The discount factor we're using is 0.0336 based on that real discount calculation between the discount inflation rate I calculated here. So let's use that. We've done it before. Sometimes we put them across the top here in terms of a discount factor and apply all the costs to that discount factor, which I think you did in the last scenario. In this case here, I'm using the formula, the discount formula, right there. So it's S12. So that's that first item. If I scroll back across, so that first cost, which will be 0, multiplied by a discount factor of whatever it is, it'll still be 0. But as I put it across, it'll correct or apply the correct calculation in the right cell. So just like that, have a look and familiarize yourself with that calculation. Once I get rid of the comma, the kind of color-coded cell structure shows up. Different lock there. The dollar before the column locks the column. The dollar in front of the row locks the row, or you can lock both with $N, $12. In this case, I only want to lock the column. So I'm going to click enter. I'm going to use the little crosshair. I'm going to scroll that all the way across, and that should discount every item there. So you should see that going down. If it was 642,000 in year 25, it's down to 281. So the greater the discount rate, the more that will discount. And then I'm going to pull that down to year 20. So that's my discounted costs. Now, of course, you could have many more there, and you'll have to pull them down to how many rows you have. But that's the start of what I'm kind of trying to achieve with respect to like 2 cash flows. And as I said, if you had an escalated cash flow, you would use that escalation, the isolated escalation rate of 1.75%, compounding every year. Okay, now what I want to do, and this is something you haven't done before, I'm going to try and take the costs that apply to renewal, apply to operations, maintenance, and end of life in these cells here, and do it in row 2, and row 3, and row 4. Now you can take a look at that. I've already given you the formula. It's using a sum-if formula. You can give it a go yourself if you want, but ultimately I'm going to give it to you. Sum-if, essentially looks for this column, sum if column C, well, C12 through C84, but ultimately column C, all the way down to 84. You can pull it further down if you wanted it. Look for this item, all the renewal items in that column, and apply the applicable costs here. Let's have a look at that and see what happens. So nothing. Now the reason nothing shows up there, clicked off that for by mistake. The reason nothing shows up there because there is no renewal items. You can see it there. There's no renewal items in that first year. So hopefully once I pull that across, release, and even pull it down, every item gets populated. So just check a few, 274 and 208. So 274 is that item and that item because they're both operations costs if you scroll across. So it seems to be working. You need a kind of way of checking these things or spot checking them. Looking at this was the first year we really had a replacement. So our renewal, and it turns up there. I don't know, is there a year we have 2 renewal items? Well, there year 20 we have 2 renewal items, and you'll see that they're adding it together. So those 3 costs should pretty much equal those 5 costs, and that's kind of how you check it. Okay, do the same. Of course, in this case, it's NPV costs, net present value costs. So it'll be looking for these cells in that column. If I get rid of that comma, it's a slightly different version of the same formula, except applying it to this column instead of the first column in the real costs. So once I do that, nothing's showing up because again, there's no real renewal costs. Scroll across and then pull down. Okay, so that's essentially calculating my costs for renewal items, costs in each year, costs for operations items, maintenance items, and the life items. Now what I might do is I might sum those costs. Actually, before I do that, I'm going to sum the actual real costs here. So let's get rid of that. What that essentially does, it'll sum this item, the real cost of the entire life cycle of that real cost item, our first cash flow there. I can just pull all those down to there. Do the same with summing the net present value. Them down. Okay, so that's just summing these line items instead of summing the costs per year. So the total net present value of this one item is 923,000. The real cost is 2,937,000. Okay, I'm going to check. I always like doing some checks. I'm going to run the net present value another way. What I'm going to do is just delete it there, actually, just so you can see. I'm going to calculate the net present value on the real costs, not just sum the net present value cost that I've calculated. I'm going to do it, and we've done this before, NPV, open brackets. I need to find the rate first. There's the rate, okay? Or actually, in fact, that's the rate really I should be using. If I go back, it's the factor, okay? Because this one is different. Comma, okay? And then I'm going to run this series across here, across my real costs. So it's going to discount that series of cash flows. So there we go, and I click enter and see and hope that it comes up the same, and it does, 923. Now I'm just going to pull that down. It should work by applying the right formula. If I double click, yeah, so it's pulling that, and then that series, double click this one, pulling that series. So whether I do it by just summing my series of net present values, like for example, if I didn't need to see this cash flow, net present value cash flow, or I didn't need to graph it, I could just do that calculation based on my real cash flow. I'm showing you a few different ways. So that's that. I could hide that column because I've already got it there. So I've got my real cost and my net present value, and that's the check. This one is just going to sum, just get rid of it there, is going to sum that line and then pull it down. Ooh, there we go. Okay, and the same with this. Essentially, I'm going to equals sum open brackets, and I need to sum my net present value. Oh, ran past it. And that'll jump back and then pull those 4 items down. All right. And you can do a few checks here. Well, it's already kind of coming up there for you. That sums that at 75. That sums that at 29. So your total MPV for this scenario is 29,834,075, and your total real costs. Now, if you wanted it, you could kind of do just to check sum all these. Hopefully it'll come up to the 75,756, and it does. Just delete that again. And do the same with this one. So do a couple of checks first just to make sure everything is in order. 29,834, that's okay. So I'm happy enough. We've basically done exactly what I want to do here in terms of the input sheets. I ran the actual costs for the renewal, operations, maintenance, end of life, pulling a few sum-if formulas and then applying that to the different years. We did a calculation on each line item for real and NPV costs. So hopefully you can follow that. I know it's a bit of a, let's say, a mouthful in terms of what we're going to do, but everything that we've done here, you've done before. The only thing that you may not have done before is the sum-if calculations, but hopefully you can get your head around that. Ultimately, it's looking through this column for this word and applying the costs that are associated with those 2 items in the cell I'm looking for. Now, again, the better Excel you are, the more you'll be able to use that in terms of locking cells and rows, but it's a proficiency that you can develop, and certainly over the course of these 6-7 different exercises, you're developing, which is nearly more important, your proficiency in Excel. So moving on from that, we're going to look at the summary page. Okay, so for this exercise, we're going to use the summary page proposed by the International Construction Management Standard. So on that ICMS coalition.org webpage I showed you earlier is an Excel spreadsheet, as well as the actual ICMS 3 itself. But there's a spreadsheet produced by the coalition. And on that spreadsheet, there's a number of different sheets and workbooks. I've taken about 4 or 5 of those sheets because they're applicable to what I want in terms of producing a life cycle cost. So I guess the most applicable sheet on that workbook is ultimately the summary page. And then there's a number of kind of additional sheets here, which I've also pulled into this exercise. And that just provides the breakdown structure for the different categories. So you'll note that there's a number of different levels to the ICMS structure, which I've said before. Level 1 is the fact that it's a building or a tunnel or a bridge. Level 2 is the category. So that's whether it's construction costs, renewal costs, maintenance costs. And then we've got the group level. And that's the fact that it's demolition, site preparation, substructure, superstructure, etc., etc. We're not getting down as far as the subgroup category, subgroup level 4 with life cycle costing. Interesting enough, they actually don't provide that further breakdown structure in the summary page of the LCC. So there's also a summary page for carbon evaluation. There's also a summary page for construction costs. But for this exercise, we're doing LCC. So that's the actual sheet I pulled in. Now, the sheet or the summary page is pretty self-explanatory. For the nature of this exercise, I've given you the construction costs. Now, you'll probably be aware at this stage, in terms of construction costs, both the net present value and the real costs in terms of construction costs are the same. So those 2 columns for construction will be the same costs. And ultimately, we pulled in a cost, so I've given you the exact same cost there in terms of construction costs. There's also these percentages in the last 2 columns of the summary page. Now, they're both the same at the moment, but the first percentages are the percentages of the category cost. So 3%, 1,512,000 is 3% of the 62 million construction costs. The next item is 8%, so it's essentially 4,666,000 divided by 62 million is 8%, and so on and so on. These costs here are ultimately these items divided by the the total life cycle costs, which includes everything, and they'll be obviously considerably different or less than the category costs. They're coming up the same because that's the only item I have in there right now. I'm going to show you how to do one item in terms of pulling costs in, and you'll be able to apply that then to operations costs, maintenance costs, end of life costs. The main thing in terms of coding is essentially that you have a code in your input sheet. You've got the respective categories in, and you may even probably should put the level 3 in. So you have a code, a level 2 heading, a level 3 heading, and they're essentially what we're pulling from here. So every cost item or every lifecycle cost item should be given a code. Now, if you're really smart, maybe you just put the code in, and based on the code, you'll be able to tell the software, the spreadsheet using formula, what's renewal, what's operations. And I have other spreadsheets in that I use that have a good bit more automation, but I don't want to make it too complicated for you guys, so I'm giving you something that you probably could understand fairly easily without any background in Excel by just following these exercises. So we went through that, and hopefully you have a good handle on how those items are put together, and by all means you can use this for a project in work or for a project in college, build on it, add functionality in, change things around, do what you need to do. It's just a proposal. It's not a fixed way of doing things. It's just trying to show you as many examples as I can. Ultimately, what I want to do is I want to pull the right costs into the right category based on the codes. Now, there's a formula we can use. So I'm going to start with the net present value. As I said, there's M as paid here. That's essentially the real cost items. There's the discounting factor. Well, ultimately, that's all going to be 3.36%. And then we value. So let's just start with the net present value. Now, I've given you the formula in here. Again, similar to what I've done before, I put a little comment in it just to make sure that you guys kind of know or have that so I can show it rather than it being in there. But if I took it away, you'll actually now see it. Now, there's nothing in that cost because I don't have any demolition site and formation costs. I might do this formula so you can kind of see what's going on. Hopefully I can remember how to do it, so I'll just delete it. Okay, so I want to pull in any items into 3.0. I want first of all the formula to search for the costs and apply the cost to the different code if that code is there. So let's kind of use that to do it. I used sum if before, but I'm going to use a slightly different here. Sum ifs. Open bracket. Now, what's the sum range? Well, I got to jump over here to my own costs. The sum range ultimately is going to be click. It's going to be my Q, my net present. That's my net present value. Yeah. So Q. I can do this because there's no code against these particular costs, so it won't pull. It'll only search for the actual items here, 301. And apply anything applicable to 301. So that's then comma, and then it's going to search for the code, so BB. So it's going to search for the code, and then I have to then go back with another comma, go back and click on 301, and then put a brackets at the end. So that essentially what was hopefully in there equals sum ifs. Slightly different than what I used before. Open brackets, look for the actual sum column. I think it was the other way around when I used sum if without the is. Then look for the code column and then look for the code. And then if I hit enter, I'm going to get nothing there. But if I pull that down, I should get populations costs there. So I've got only 2 renewal items. And hopefully that is the case. If I go back here. 304 and 305. They're the only costs I have. So what it'll essentially do there is it summed my 2 304 items. Let me jump back. Sum those 304, those 3 items in fact. And hopefully those 3 items, if you calculated them, would be equal to, what's this case? 1.6, and I think they are. If you wanted to, you could kind of just do a little calculation and see that's the case. So there you go. If I double click them, it's the same scenario. It's just moved down looking for 304 instead of 301. And that's that. And then if you wanted to sum those, 15,047, just make sure it is 15,047 for renewal costs. And there it is. So you can see that it's kind of pulling the right formulas or right costs into the right codes. You can apply the same scenario here for your real costs. So if I said equals sum sum ifs, brackets, sum range, hop over to the sum range. In this case, it's P, not Q, because that was entry V. P, comma, up here. And then look for the code, okay, or the code column, and then jump back and click on 301. Close the brackets and click enter. So again, nothing there. Now, again, I should see 2 costs in these 2 rows. So let's just do that and pull that down. And there you go. And sum that. $46,483, and is it 46,483? So you're following that same methodology for operations, using the right code. Same for maintenance, same for end of life. I think I have the right formula in here, but just double check it, the right formula in there. So now I have those 2 populated. I haven't done the percentages, but it is up to you to figure that out. I haven't done the costs per square meter, but that's fairly straightforward based on what you see there. It's just that cost divided by that square meters. And then you'll have your percentage cost based on the category and the cost, and then you'll have your percentage costs based on the overall life cycle costs. So that's a nice, neat way, or I guess an intelligent way of pulling costs based on codes. And this is something that would be very useful for any kind of coding, whereby you've got an input sheet and you're assigning codes in the input sheet, and then you want to sum based on those codes. So I want to put both or 2 or 3 of the items that I assigned to code 304 in that one row rather than have them individually, and that's what's essentially happening there. Whereas the other time I used something similar when I was doing the sum if in the Rome input costs. So as a solution, you're going to have to figure this out yourself in terms of do it, and then I'll provide a solution in another spreadsheet, just like I've done in other exercises.